So today we're going to finish up 1.6 by doing absolute value inequalities. Okay, we're going to do them very similarly, can't say that word, to equations. So we've got x is less than 5, and then we're also going to have x, and remember we make that right side a negative, but this is now an inequality. So if we multiplied by a negative, we got to flip that inequality. Alright, so now if we graph it, we're going to need -5 on the left, 5 on the right, and then we need all the values that are going to be smaller than 5. So that would be values like 4 and 0 and -3. Okay, but 5 and -5 won't work because they don't. It's not allowed to equal 5. Okay, 6 isn't going to work. -18, a billion. Those numbers aren't going to work. Okay. Number 2, we're going to have x is greater than 5, then also x and -5, but we're going to make this less than. So if we think about the graph here, we want the opposite of what we had over there. We want values to be bigger than 5. So we want, first of all, I'm not really sure why I did a negative there. All right, we want values to be bigger than 5, like 6, 18, 724. Okay. Also, the negative is also going to work because the absolute value would make it positive, therefore bigger than 5. So notice what we have here. These are your typical compound inequalities. And the one on the left is typically written as an and the one on the right is written as an or. Okay. Well, why is that? All right. Why did this one become an and this one become an or? All right, well, look at our original equation. We have the absolute value is less than something. All right, when it's less than, all right, that's what you're going to think. Less than, you're going to use an and in between your inequalities. Over here, when you have the absolute value is greater than something, all right, when it's greater, you're going to use an or. Okay? That's what you're going to try and teach yourself. Okay? Or try to remember. Or some other acronym or something you want to use. Alright, so let's put it to use. Okay? For number 3, you would do x plus 2 is greater than 5. Alright, that's your first one. You just drop the bars. Well, then it's a greater than sign, so it's going to be or x plus 2. Then you flip everything, less than -5. We solve them. X is greater than 3, or x is less than -7. We graph it, -7, 3. We want an or. Hopefully you remember that means you shade whatever it says. So everything bigger than 3 and everything less than -7. There's your answer. Alright. Now for number 4. Okay. We're going to have 3x minus 5 is less than or equal to 13. Alright, try this one on your own. Pause the video. Pick it back up. Alright, less than, so it's an and, 3x minus 5 is greater than or equal to -13. So we add this up, move things around. Give me a second, I gotta catch up to you guys. What is this? -8. X is greater than or equal to -8/3. We graph it between, and it's and, so less than or equal to 6 and greater than or equal to -8/3. This is your nice typical and statement. There you have it. Alright, let's keep working. Alright, just 2 more pages. Alright, so let's do number 5. Alright, what's different about this one? Ah, yes. The absolute value bar is not by itself. Okay, so we got to work on that. So this is the absolute value of a minus 4 is less than negative 6. Okay, now we can solve it. A minus 4 is less than negative 6, less than, so and a minus 4 is greater than positive 6. So add the 4. There we have it. Now we shade. We know we need negative 2 and 10. So less than negative 2 and bigger than 10. Uh-oh. And is overlap. Nowhere are these arrows going to overlap. So this is somehow no solution. So why is it no solution? Oh yes, because an absolute value can't be less than a negative. Okay, it can be smaller than a certain positive number, but it can't be less than a negative because it's positive, right? So if you notice that before, all right, then you automatically know it's no solution. If you don't catch it, the algebra will save you if you know these tricks. Okay, let's keep going. All right, number 6. Do the same thing. Get that absolute value bar by itself. We get the absolute value bar of 5x. Sorry. Oh. 5x is less than negative 5. Ah, what did I not do? Oh, I didn't flip my less than sign. Alright, you got to watch out for things like that. Okay? So, it's now greater than negative 5. That is doable. That is 5x is greater than negative 5, or 5x is less than positive 5. So, x is bigger than negative 1, or x is smaller than 1. So, we want negative 1, positive 1, or, says you graph whatever it tells you to, bigger than a negative 1, smaller than a 1. Uh-oh, that's all reals. All real numbers. Well, why is that? Oh, did you look? Did you see it? The absolute value has to be greater than a negative. Of course it's going to be bigger than a negative. It's going to be positive, and every positive number is bigger than every single negative number. So yeah, of course any number's going to work. You'll see that now? I love it when the algebra sneaks in there. Alright, sometimes it's easy to catch, and sometimes you don't catch it until you do some work. Okay, so just look out for it. Alright, here's number 7 and 8. You guys can give this a shot. Alright, pause and unpause, all that good stuff. So here, we've got x plus 2 is less than or equal to 2x plus 7, and x plus 2 is greater than or equal to negative 2x minus 7. So I'm going to work this one out. So we get negative x less than or equal to 5. So x is greater than or equal to negative 5. And 3x is greater than or equal to negative 9. X is greater than or equal to negative 3. So we graph those. Negative 5, negative 3. And we want the overlap, so anything bigger than negative 5 and anything bigger than negative 3. So really the only place they overlap is this part right here, and this is extra info. So our answer is x is greater than or equal to negative 3. There's your answer. Okay. Alright, next one, number 8. You got to move that 10 to the other side. So I get a lot of kids that write this, and then they see it and think no solution. Ah, but there's a negative. That's like a negative 1 out front. What is that negative 1 doing to that absolute value? Multiplying. So let's get rid of it by dividing. So we get the absolute value of x plus 2 is now greater than 4. Now we've got it. X plus 2 is greater than 4, or x plus 2 is less than negative 4. So x is greater than 6, or x is less than negative 6. Oh, just kidding. I wanted to make them both 6. That doesn't work. 4 minus 2 is 2. Silly me. So we graph it. We get negative 6 on the left, 2 on the right. We want to graph or whatever it says to do. So everything bigger than 2, everything less than negative 6. And there you have it. All right, so that's it for absolute value inequalities. Please do your assignment and submit that on time. All right, good luck, and come to me if you have any questions.